Hello, this is our lecture 2 of group theory related to GEM. This lecture is specifically made for IIT GEM mathematics. So here we'll do some. In previous lecture, I have discussed about some theories and short tricks for doing the problems. Now we'll solve some PYQs on those topics. So our first PYQ is from 2019. The question is given that question 1, let H and K be subgroups of Z144 if the order of H is 24 and the order of K is 36. Then what is the order of H intersection K? You have to find. The given options are 1 A3, C6, say B6, C4, D12. So we have H and K are subgroups of a Z144, which is clearly a cyclic group. So H and K also are cyclic groups. Now, as we know, if a number K divides the order of a cyclic group, then it must have 5k elements of order. Okay, we know this from previous classes. Now, so H and K both have elements of order 12, since 12 divides order of H, which is 24, and 12 also divides order of K, which is 36. So order of H intersection K must be greater than or equals to 12. From here we can say it, since 12 divides both. Now also this H intersection K is a subset of K, and H intersection K is again a subset of H. Now by using Lagrange's theorem, we can say order of H intersection K divides order of H, and again order of H intersection K divides order of K. So if order of H intersection K is less than or equals to 12. So what we are getting, order of this is, if this is equation 2 and this is equation 1, from equation 1 and 2 we can say now order of H intersection K is 12, and so this is the answer. This is the required answer. So option D, 12 is the required answer. Next problem. If problem 2, let G is equals to a set such that n belongs to n, and n is less than equals to 55. This comma GCD of n, 55 is equals to 1. This is question from 2019. Okay, this G be a group under multiplication modulo 55. Let x belongs to G such that x square is equals to 26 and x is greater than 30. Then x is equal to what? So you have to find x. The given options are A 31, B 30, C 45, D 46. Here clearly the G is a group of form U55, i.e. multiplication. This is a multiplication modulo 55 group. So now take x is equals to 30. We have to check this by putting the values and check whether our conditions is satisfied. So we are first taking x is 31, and this will get then x square is equals to 961, and 961 is equals to 2626 mod 55. By calculating we can get it. So x square is equals to 26 for x equals to 31, and x again, if we take x equals to 46, we'll get x square is equals to 26 for multiplication modulo 55. So option A 31 and option D 46 are the required answers of this question. So this is a MSQ type question. Next, we have to state which the questions of 2018. We have to state which of the questions is true. Following is true. The given statements are: 1. Zn is cyclic if and only if n is prime. Every proper subgroup of Zn is cyclic. Every proper subgroup of S4 is cyclic. This is clearly not true. So we know it from previous classes. If every proper subgroup of a group is cyclic, then the group is cyclic. This is not true. This is not true. This is also not true. We can give an example of like Q8, where all the proper subgroups are cyclic, but the group itself is not cyclic. or even we can give the example of K4. So we are left with the option 1 and 2, and option 1 is clearly not true for, so our option 2 will become right. Next problem, and option 2 is right. What is that? Since if Zn is cyclic, every subgroup of a subcyclic group must be cyclic. So every subgroup of Zn is cyclic, and this will be true. This is the explanation. Next, yeah, the next problem is from again 2018. The question says that consider the group S square is equals to that a comma b belongs to z set of integers under component wise addition. Then we will add them by under with components, and then which of the following is true. Option A comma b belongs to z square such that ab is equals to 0. B a comma b belongs to z square such that 3a plus 2b is equals to 15. C a comma b belongs to z square such that 7 divides ab. D a comma b belongs to z square such that 2 divides a and 3 divides b. So let's check the answers. For first case, S1 is also like this: a comma b belongs to z square such that ab is equals to 0. Now since 1 comma 0 belongs to S1, 0 comma 1 also belongs to S1, and the AB is 0. Since the AB is 0, both the elements are, the product of A and B are 0, so both the elements are belongs to S1. But 1 comma 0 plus 0 comma 1, which is our component is binary operation, is giving 1 comma 1, which does not belongs to S1 because product of these two is not equals to 0. So this will, the option first will be rejected. Next, S2 is set like this: AB belongs to z square such that 3a plus 2b is equals to 15. Now since 0 comma 0 does not belong to z square, it does not belong to S2, so the identity element does not belong to S2, so it will not form a group. So S2 is also rejected. The next option, option C, S3 such that a comma b belongs to z square such that 7 divides AB. Now let's take, since we have 1 comma 7 belongs to S3 and similarly 7 comma 1 also belongs to S3 because product of AB is 7, and in next case also product of AB is also 7 and 7 divides AB. So S1 and S3 belongs to S3, but the component wise addition 1 comma 7 and 7 comma 1 gives 8 comma 8, which does not belongs to AB, which does not belongs to S3 since 8 into 8 does not divide it by 7. So we are left with our last option, option D, S4 is equal to such that a comma b belongs to z square such that 2 divides a and 3 divides b. So since 2 divides a, let a is equals to 2k and b is equals to some 3l, where k and l are some integers for some k and l. Then we have let two elements of the group S4. These two elements 2k1 comma 3l1 and 2k2 comma 3l2 will belongs to the element S4, and the sum 2 into the sum what will give if you add them 2k1 plus k2 plus 3 into l1 plus l2, which is, and this l1 plus l2 is a multiple of, this term is obviously a multiple of 3 and this term is obviously a multiple of 2, so this will obviously belong to S4, so our condition is satisfied, so option D is the correct one. So I am ending my lecture here. We'll continue on this topic from the next lecture. Thank you for watching. Please like, share and subscribe.